This line here is a tangent to the circle, and a tangent to the circle meets the radius at the point of tangency at 90 degrees. So we can work out this angle. It's 90 take away 25, that's 65 degrees. And angle P then is found by subtracting 65 from 180. And that gives us 115 degrees. Because this angle here is a straight line. What we can do here is split this triangle right down the middle. So this angle is half of 52 degrees, which makes it 26 degrees. Here we have a tangent and a radius. So this angle is 90 degrees, and that means that this angle here is 90 take away 26. And that's 64 degrees. Now, what we have here is another 90 degree angle. So to find Q, it's 90 take away 64, the angle that we've just created. That gives us 26 degrees. Now, what we have here is a triangle drawn within a semicircle, and any triangle so drawn has a 90 degree angle at this position here. Here we have a tangent again, and a tangent meeting a radius produces a 90 degree angle. So this angle in here is 90 take away 48 degrees, and that's 42 degrees. And this angle up here then is 90 take away the 42 that we've just calculated, and that gives us 48 degrees. First thing we can do is mark in a 90 degree angle here. This is a right angled triangle. We're told that the radius is 30, so I can fill in 30 here. QR is 42, so 42 divided by 2 is 21. Why am I dividing by 2? Because this line PT, it cuts the chord QR into two equal lengths, and we can see that. If that's 21, that's 21. If I want to work out, I'm going to work out CS, so CS squared is 30 squared take away 21 squared, 900 take away 441, and that gives us 459, and the square root of that is 21.42 centimetres. What we want to do is to work out the length of the line ST. So we know that CT, which is a radius, is 30 centimetres, and we've just worked out CS, so ST then, if you look at the diagram, ST is CT, the radius, take away CS, and it's 30 take away 21.42, which gives us 8.58 centimetres. The diameter of this circle is 150, which means that the radius is 150 divided by 2, which is 75 centimetres. What I'm going to do is to draw a radius in like so, and I'm also going to draw another radius in like so. So really what we have here is two calculations involving Pythagoras. AB is 96, half of 96 is 48. So this line here is 48 centimetres, and 1/2 of 108 is 54. So this line here is 54. Let me just call this, well, let me just use Pythagoras then on 2 twice. So EO squared is 75 squared, take away 48 squared, and that equals 3321. And if we square root that, we get 57.628 centimeters. OF squared is 75 squared, take away 54 squared, which gives us 2709, and if we square root that, we get the answer 52.048 centimeters. So the length of EF then is found by adding these two numbers together. And that gives us 109.68 centimeters. Calculating the gradient is very easy. To the gradient of KL, remember the formula is y2 minus y1 over x2 minus x1. So that's 9 take away 1 over 7 take away 3. That's 8 over 4. And we should always simplify a fraction. The gradient is 2. The gradient of RS is, I'm not going to use the formula, I'm not going to write the formula down, so it's 2 take away 3, that's y2 take away y1, and then 2 take away minus 4. 2 take away 3 is minus 1, 2 minus minus 4 is 6, so it's minus 1 over 6. The standard form for the equation of a straight line is y equals mx plus c. So if we look at y equals 2x minus 1, it's in standard form, so the gradient is 2. The gradient is not 2x, the gradient is 2. For part B, it's also in standard form. The gradient is minus 3 over 4. Part C is not in standard form. What I'm going to do to get it into standard form is first of all add 8 to both sides. So 4y minus 6x equals 8. Then I'm going to add 6x to both sides. So 4y equals 6x plus 8. I'm going to divide by 4 because I want to get 1y. 8 divided by 4 is 2, and really I want to simplify as well. Simplify the fraction. So the gradient of line C is 3 over 2. The standard form for the equation of a straight line is y equals mx plus c. We are given the gradient, it's 2. We're also given the y-intercept, that's 2. So the equation is y equals 2x plus 2. In question B, same idea, y equals 4x plus minus 3, which we'll just write as minus 3. And in part C, y equals 1/4 x plus 7. Now in part D, we're going to have to work out the gradient. So y2 minus y1, 8 take away 3. x2 minus x1, 10 take away 0. That gives us 5 over 10, which is 1/2. And we know that the y-intercept is 3, so y equals 1/2 x plus 3. Part E, the gradient is 9 take away minus 3 over 4 take away 0. So that's 12 over 4, which is 3. Y equals mx plus c, y equals 3x, and the y-intercept is minus 3. Now we can see that this line has a negative gradient, so 4 take away 0, y2 minus y1 over 0 take away 12, so that's 4 over minus 12, that's minus 1/3. Y equals minus 1/3 x, and the y-intercept is 4.